All right, hello everyone. Welcome back to week 8 of the Vulkan terrain series. This week, what I've done is I have explored Odin, the programming language, as I said I was going to do last week. So essentially, that's what I've decided to write my ECS in, just for fun, really, because at the end of the day, I don't think I can use Odin with C++. I tried looking into it, but there doesn't seem to be support for it. Um, there is support for C in Odin. Odin can interop with C pretty well, but with C++, um, it's not there, is my understanding, right? So yeah, so because of that, it's gonna be C++ for the game engines ECS. But still, I'll take you through how this works. So essentially, this is a similar setup that I had going on to my object-oriented ECS, but it's written in a data-oriented style, or I guess in a procedural style technically, um, because of course that's what Odin is. Odin is a procedural, sort of data-oriented, focused programming language. Um, it's not intended, it doesn't have any object-oriented features or anything like that. So here we have so basically the way this works is we're first creating our entity, right? Because we still need the concept of entities for the ECS. And here an entity is literally just a number, right? It's literally just an ever increasing counter, right? So yeah, so that's the entity. And then we have the component to entity function. And really all this does, it takes the entity, it takes the component, and it instantiates a component with the same ID as the entity, right? So it's really straightforward, and it uses a switch case to do this, right? So if I delete this part, one thing you'll see that's really cool about Odin is if you have a switch case that is incomplete, where it doesn't cover all the cases, Odin will actually give you an error telling you that you should complete the switch case, right? So that's really good. That makes this kind of programming very viable, right? And you'll see also that, yeah, you have to do this with a switch case because again, there's no polymorphism or anything, right? So yeah. And of course, entity isn't an object or anything like that. So of course, you do it that way, right? And I'll show you the components as well because I figure that's worth looking at. So the components all, I guess, quote unquote, inherit from this base component, right? So this base component just has an entity ID, and the thinking is maybe I want to add more stuff to each component. Maybe I want to add some metadata or something. I'm not really sure. But if I wanted to do that, I would just add it in here, right? And it would be present in every component, right? So, and then here we have the physics component, right? So it just has the base component as a field, right? So it's a struct with a struct in it, right? That's how that works. And we have gravity, friction, collision, all of that stuff, right? Same for the graphics component, same for the transform component, right? Really straightforward stuff. And then we have the component types, which is just an enum. This is because there's no such thing as like well, there's types, but types can't inherit from other types, right? So I can't just say, oh, I want a component type, right? Like the add component function, I can't just say I want a type of component, right? In the function signature, I mean, like here, I can't just say this can be like a component type, because of course, like inheritance doesn't exist, right? So it has to be an enum, right? It has to be an enum value. There might be a different way of doing this as well that I'm not sure of, but I think it has to be an enum. And then we have the actual components here, which are just like arrays, really, just dynamic arrays. A dynamic array, by the way, is an array that can resize. So it's a C++ vector, is the idea, right? All right. So yeah, and of course you can add more components here as you want. Although I would prefer it if there is some way to add a component more easily, because currently you gotta create the component, then you gotta add to the enums, and then you need to create an array down here, right? So you do 3 steps, and technically 4 steps, because you need to also go to the entity and then add another case here. So that's a bit of work. I would prefer to just have 1 step. I'll need to look into that, how to do that for sure. But yeah, And yeah, and now let's go to the actual systems. So you'll see that the physics system, so this is some pseudocode I've written out. This is not actually how it will be done. Um, so you'll see, I say I have no idea how to do this well. So this is how I imagine I would need to write the physics system with my current level of understanding. So the way it works is you loop through all the physics components, then you get the entity ID, right? And this is something that could potentially happen. I could potentially do it like this, right? So the problem here is the physics uh, components and the transform components need to be associated with each other, right? Because they both belong to the same entities, right? So what I need to do is for every physics component, I need to get this transform component that is attached to the entity, right? So one way you could do this is you could use the entity ID as the index into the component array, right? And this was actually the solution I used for like the first data-oriented ECS I made. Is I used the entity ID as the index into the array. But the problem is you end up having like an array with a bunch of like null values, right? Because you need to pad the array. So what I mean by this is, let's say you had let's say you had three entities in your game, right? Entity one has a transform, so every entity will have a transform component, but entity one has a physics component. Entity two does not, entity three does, right? So you need to have three things in your transform, in your physics component array, but one of those is just null, right? It's just polluting your cache, right? So it's not ideal to do it that way, right? I need to do a bunch of last minute decision making is what they call, what they say in data oriented terms, where I would need to have like a boolean of is it valid or not, right? And then if it's invalid, then skip the component, right? And that also introduces branching into this whole equation, right? It's not pretty, right? We don't want any of this. So yeah, ideally, we would not do that. So yeah, I'm trying to figure out a solution. So this ideally would not happen, right? So what's the alternative to that, right? The alternative to that is to loop over every single transform component and find the one with the same entity ID as the physics component, right? And then we check if they're equal, and then we can do stuff, right? So for every entity, essentially, so assuming the physics component is the entity to a degree, right? That is an O of n loop, right, to get the transform component. Assuming that the transform components, there's an equal number of transform and physics components, right? Assuming that it's an O of n operation to get the transform components. And overall, for every entity, right, in the game to update all of the entities, right, this is an O of n squared operation, right? Again, assuming the physics components are the same number of physics components as transform components. That's an O n squared operation to run this function once. So ideally, it's not. Ideally, I would not do it like this. There definitely is a better way of doing this, but I'm not sure what it is. I need to look into it a bit more. My data oriented skills are definitely a lot rustier than my object oriented skills because of course I'm more used to that. Um, so yeah, I gotta figure that out. But yeah, that's all for this week. Next week, I hope to finish up the Odin ECS. Again, this is sort of like a side quest, so I still do want to finish it, so I will do that. And then I will get back to working on my C++ ECS that I'll also be writing in a procedural style. And of course, it's going to be data oriented as well. Right. So yeah, I'll see you guys next week for that.